Hello, my name is Jaasim Reyaz, and I'm going to discuss my research, which is blockchain-based EXE registration and recursive verification system to detect and prevent EXE-based malware. So, first of all, giving a brief about my research topic, uh, the question here is, are the existing malware detection solutions effective enough, and is the antivirus capable of detecting all malware? Also, can blockchain be an alternative to antivirus and other malware detection products? Since we know that Windows exe are the major file types used for to spread the malware, so can this be stopped once and for all using blockchain as an alternative? I have proposed an innovative and effective research model, which is blend of blockchain and file checksum technology to eliminate Windows exe malware. So discussing about literature review, uh, what is malware? First of all, so malware is a malicious software commonly used by attackers to infect systems. It is supported by many file formats, with exe being the first in the ranked list. Statistics highlights 38% of file format used to spread malware is exe. Existing solutions including antivirus are not effective enough to detect all the malware. Coming to the literature survey, blockchain versus antivirus. So in my research, I have mentioned that antivirus has its own limitations, and experts say only 45% of malware are detected. There have been many attempts and researches going on to produce innovative solutions alternative to antivirus. I've also discussed blockchain, the role of blockchain in cybersecurity, and I've discussed the concept of blockchain and the distributed ledger. Existing blockchain-based solutions alternative to traditional antivirus like Block AV, etc., are also discussed in the report. So, proposed research method. I'm proposing a blockchain-based recursive distributed verification and checksum-based EXE registration system for EXE malware prevention. Uh, Distributed ledger registration repository. So a simple file-based repository to store all the Windows exe registration details that include file checksum string and all the relevant file and author details is used. Windows exe global registration process. So this is a blend of manual and automated tasks. The idea behind is similar to the certificate authorities who verify companies and their websites before authorizing and issuing certificates to secure the transactions. Coming to distributed ledger repository updates. So basically there are two types of updates here, the global update and the local update. Uh, in the global update, distributed ledger is used for the verification of the data in the multiple locations, and a simple file-based repository is used and stored on all cloud instances, which are used for the update of the repository. In the local update, storing the repositories can be stored locally as well on the client system, which can then be used for updating locally. Now coming to Windows exe checksum generation. Checksums are generated for files to verify its integrity after it is transferred from one place to other and stored at multiple places. Different encryption techniques are used to generate checksum strings for a particular file. It prevents corrupt transmission of files and also ensures that it's not tampered in between. Now, coming to recursive verification and malware identification, this is a very major task in this research. I have proposed an algorithm to perform recursive verification and malware distribution. And when an exe is open for the execution in the client machine, a Windows service is executed before executing the original files, and it is then verified before the actual exe file is executed. Global alert system. A .NET-based alert system is used to alert all the global and local repositories in case any exe file is found suspicious whenever checksum verification fails during recursive verification process. Offline verification system. Uh, Usually antivirus products work without connecting to the internet. To achieve similar kind of a feature, I'm proposing an offline verification model through online and mixed mode models. Are though The mixed mode models are highly recommended. Now coming to online verification system. In this research, it is recommended to use online model, which recommends to be connected to the internet to take the full advantage of the up-to-date global repositories and thereby minimizing the rare chances of blocking a valid file execution. Now, research techniques and approaches. My approach is mainly based on the combination of idea behind blockchain and checksum-based global EXE registration. I have proposed to build a simulated environment for experimentation, which consists of the number one, multiple cloud instances to stimulate distributed network. Number two, a simple file-based system to act as distributed ledgers to store exe checksum details. Number three, multiple .NET and C# based Windows services and applications to perform required activities. .NET is recommended since its compatibility is very good with Windows system. So this is the Windows EXE malware prevention and detection design spec, which gives us an idea on how the malware will be detected and prevented from being executed. And this is a sequence diagram, which gives us an idea how the verification is done and if there's any failure or if it's passed, and uh, how the sequence of that verification goes through. So this is the UML diagram, which shows the both pass scenario and the fail scenario. So on the left side you can see the pass scenario, while on the right side there's the fail scenario. Now coming to the future scope. In this research, I have proposed a model based on blockchain's distributed ledger concept to detect and prevent exe malware execution and infection on target systems. The experiment does recursive verification on independent systems and compares exe file checksum. If checksum doesn't match, verification fails and execution is blocked. In this research, it's not discussed on what needs to be done with those EXEs which fail the verification process. As part of future scope, a new component can be proposed to keep track of these unknown EXEs and further track down the authors who are responsible for them. With this, I come to the end of this presentation. Thank you very much.